Here from Adrian Griffin, Lithium Australia, to tell you all about his projects. So Adrian, the stage is yours.
Thank you, Leo. Lithium Australia is all about conservation of materials. We're, to a large extent, a technology company, although we do have quite a substantial exploration portfolio, but we have been developing processing technologies primarily for the extraction of lithium, revolving around low energy and low cost, and also product recycling. I'm glad to say, Leo, I can actually read it just. Every time I come to 121, I say to Leo, if you wear multifocal glasses, these things are too low to read. But I need you to hold it up. So the things I'm going to talk to today about the energy metal cycle, disruptive technologies that you can use to capitalise on those cycles, sustainability built in by using those technologies, and various investment opportunities that we have available. There's the board, current market capitalisation about $60 million. Currently have about $18 million in the bank. An additional facility for $15 million drawdown as a convertible note, and a few other bibs and bobs around the place. So what we aspire to do is close the loop on the recycling of, or the production and recycling of, energy metals, and we have a number of divisions within the company set up to do just that. There's silage, which is processing technology for primary minerals. That technology revolves around the digestion of minerals without the requirement for roasting. Now, that's most important. That's how you get the energy footprint down, and in doing that, we end up taking into solution a lot of other metals that you can recover as byproducts in the process. VSPC technology, which is probably the world's most advanced cathode powder production technology. I'll take you through that in due course. And RCARC, which is recycling technology. We have very heavy research programs going in North America and Australia for the recovery of metal out of lithium-ion batteries. Not only lithium-ion batteries, we're looking at the alkaline batteries as well, because they're a bit of a scourge on the landscape, in that most of them go into landfill, which indeed is the case, by the way, with most lithium batteries at the moment. Recycling rates around the world are less than 10%. And there's been an enormous amount of money expended on those materials to put them in the batteries, and the batteries are high grade in terms of a source for processing. And then we have a fairly large, probably second to none exploration portfolio on a global basis. So this is the energy metals cycle. In the blue quadrant, we've got the silage technology, capable of taking mine wastes and other low-grade products and producing lithium chemicals. That can ultimately be fed into VSPC technology to take the lithium chemicals that further step and produce cathode powders. Normally in the grey sector of the cycle, that should be landfill. But we're trying to pull that back by using RCARC and developing the recycling technology to make sure the metals don't leave the supply chain, particularly when you've got drastic shortages of metals such as cobalt and, to a lesser extent, lithium. So what makes it tick? It's the technology and the processes that make it tick. And here's the first of them, which is the silage technology. It's effectively a sulfuric acid leach where we mix a slurry of minerals with calcium fluoride. The calcium fluoride attacks certain bonds in the silicates and ends up solubilizing the minerals. And then from there, go through a series of routine chemical processing steps, changing temperatures and pH, and dropping out materials either as waste or valuable byproducts. By the time you get to the end of that, you've got the most soluble metals still in solution. That's lithium and potassium. They're incredibly hard to get out of solution. It's amazing. So they just stay there. All the other things you get rid of. And the lithium has dropped out as lithium carbonate or other lithium chemicals. And the potassium still hangs around in solution. You've got to evaporate the solution to produce potassium sulfate, which is fertiliser. What does that do in cost terms? You can see there the average operating cost going from hard rock through to lithium carbonate. up around the $7,000 a tonne mark or thereabouts. We believe that silage will operate a little bit below that without a byproduct credit, down around $3,200 a tonne after a potassium credit. And then you can recover a whole pile of other things like alkali metal salts, aluminium fluoride, sodium silicate. And after doing that, which we won't do initially, I might add, but the ultimate goal is to do that longer term, which should make the process competitive with the brine producers right down there in the bottom left-hand corner. So where do we go with this? We have pilot tested at ANSTO, which is an Australian government laboratory in Australia, but we plan on building a large-scale pilot plant. We're currently negotiating contracts for the access to site. It's a brownfield site, so we'll be sitting there with other mineral processing equipment. It'll have available road, rail access, power, water, gas, importantly sulfuric acid, and possibly even more importantly tailings disposal, because there are already licensed tailings facilities there. We're also negotiating for the supply of what's that word? Lepidolite from other projects, and we do have our own lepidolite source just out of Kalgoorlie in the eastern goldfields of Western Australia. Plan design ultimately will be fairly flexible, and it'll be able to take a broad range of materials, and it will also be capable of integrating with an LMAX module. LMAX is some technology brought to you by Lepidico, and we happen to have the exclusive rights to that technology in Western Australia, and we will build in that plant an LMAX module. Onto the other technology that I mentioned, which is the cathode production technology, and this is groundbreaking stuff. It was pulled together by three boffins out of universities in Brisbane, and they raised amongst friends and family a staggering $30 million and spent 14 years to build the technology. And as these things are, boffins are really good at playing with the test tubes and not all that good at commercialising it, and their mate said, enough's enough. We're not putting any more money in. We've given you $30 million. This is from 50 people. These guys did a fabulous job over 14 years. Anyway, they produced some of the world's best cathode materials, and their mate said no more money, and so they shut the plant down. We recognise that as being an opportunity, and it's a fascinating opportunity in that it's very simple technology capable of producing a very, very small particle size. The scale bar on that particular shot is 10 microns. Now, 10 microns is probably the average size of most cathode powders. You'll notice most of the particles down there around 2, 3, 4, 5 probably. So it does produce a very fine powder, and that's critically important with respect to producing a cathode powder that has a high energy density. But the ultimate advantages of this process is you control everything in solution. There's very little mechanical processing involved. You control it in solution, and from the very first step, you set the particle size and the chemistry of the particle. No other process can do that. So this process gives us certainly a fast track to the production of cathode powders, and it's fully integratable with the recycling technologies that we're looking at and the silage process. So taking that one step further, you can see some cathode powders there, and the scale bar on this case is 100 nanometres. Now, a nanometre is 1,000th of a micron. Those other particles were 4 or 5 microns, and you can see the size particle we can produce here. Literally smaller than most other stuff on the market by a factor of 100. Okay, size matters. Taking you through this very quickly. There's your standard particle size, the leaders in the industry, the very best of them, and then VSPC technology. And then if I remove the large particles and we try and zoom in on this, you'll see just how much smaller. So the big sphere is a 2 micron particle, and the other things are VSPC particles. What you can do with that then is fill in all the spaces and make greater energy density. People are trying to do that at the moment with 2 micron particles, and quite frankly, that's almost a waste of time. If you do it with VSPC technology, you can probably increase the energy density of a standard cathode powder by about 20%. So that's what VSPC is all about. There are some of the facilities well advanced. We're recommissioning that pilot plant. We'll have material out for testing within the next couple of months, and this is what the ultimate goal is, taking things from mine waste right through to cathode powder and increasing the value for the products that we use on a daily basis. Fabulous uplift in price there, and that's the most valuable part of the supply chain. So investment opportunities, they're many, all parts of the operating cycle, and, well, here I am puffing out my chest and telling you how good Lithium Australia is and what we've achieved over the last couple of years. So that's the Lithium Australia story. It's about sustainability in the energy metals sector. It's about producing a better product and giving you something that's much more viable in the new Tesla that you're going to buy tomorrow. Thank you.